Hello, and welcome to the session on basic trigonometry. In this session, we'll learn what do we understand by this branch of mathematics, which is trigonometry, and we'll also understand what are trigonometric ratios. We'll then go on to understand the relationship between the trigonometric ratios. And finally, we'll understand or we'll learn about the trigonometric ratios for some standard angles. Let's begin then. Let's begin with what we did in the last lesson, Pythagoras theorem. Now, where do we use Pythagoras theorem? As you know, Pythagoras theorem gives us a relationship between the three sides of a right angle triangle. So, if I know any two sides of a right angle triangle, we can easily find the third side using Pythagoras theorem, right? We know that Pythagoras theorem suggests a squared plus b squared equals to c squared, which is the same as saying the square of the two sides which make up the right angles. If I add them, I'll get the square of the hypotenuse. So Pythagoras theorem is useful when we are given two sides of a triangle and the third side is unknown. So we need to find the third side. So it's basically a relationship between the three sides of a triangle. Unfortunately, Pythagoras theorem is not helpful if we have to find one of the missing angles of a right angle triangle. Right? Pythagoras theorem doesn't give us any relationship when it comes to angles. For that, we use trigonometry. Trigonometry is a branch of mathematics that studies the relationships between side lengths and angles in triangles. So where can we use trigonometry? Let's understand that first. As you can see, if we are given any one side of the triangle and any one non-right angle, which means we know that one of the angles in the right angle triangle is 90 degrees. But if we are given any of the remaining two angles, okay, any of the two remaining non-right angles, then we can still find the remaining two sides. So only by knowing one side of the triangle and one angle, which is non-right angle, we can find the remaining two sides of the triangle. Okay, so this is where trigonometry is useful. Okay, where you only by knowing one side of the triangle, we can still find the other two sides, provided we know one of the other two angles, which is not 90. But the most powerful situation where a trigonometry can be used is in finding the missing angles of a right angle triangle. All I need to know is any two sides of the right angle triangle. That's it. If we are given any two sides of the right angle triangle, we can go on to find the missing angles of the right angle triangle. This is what something which I cannot find using a Pythagoras theorem, right? Pythagoras theorem is purely a relationship between the sides of a right angle triangle. There's nothing to do with angles. For angles, we need to use trigonometry. So what is the premise on which the trigonometry is based on? The premise is simple. Okay, sides in a right angle triangle, or in fact, sides in any triangle are proportional. For example, let's say we have a triangle with side lengths A, B, and C, with C being the hypotenuse. And two of these angles are A and B, as in A degrees and B degrees. The third angle, of course, is 90 degrees. What's the ratio of the sides of this particular triangle? The ratio of the sides is A is to B is to C. Simple. Now, what if I were to change the size of this particular triangle proportionately, as in, what if I were to proportionately enlarge or reduce this triangle? Let's see. Okay, let's observe this triangle under a magnifying glass and let's see what happens. As you can see, the size of the triangle has enlarged, but be mindful that whenever we enlarge or reduce a geometric shape, the angles don't change. Right? Angles won't enlarge. An acute angle doesn't become an obtuse angle if I enlarge it, right? It stays acute angle. So the angles would remain the same. However, the sides may increase or decrease proportionately. So all the sides get multiplied by the same factor, which in this case is k. Correct? So that's a basic rule. If we enlarge or reduce a triangle, the angles would always remain the same, but the sides may become proportionately larger or smaller. So what is the ratio of the sides in this big triangle now? The ratio of the sides is Ka is to Kb is to Kc. Because K is the common factor across all the ratios, I can divide by that and simplify it to A is to B is to C, which was the same as we had it before we enlarged the triangle, right? So what is interesting is if the angles of a triangle remain the same, then the ratio of its sides would also remain the same. Okay, think about it. As you can see, the angles of the triangle were the same as before, right? It was A degrees and B degrees and 90 degrees. Even if I were to enlarge it and reduce the triangle by keeping the angles same, the ratio of the sides, we're not saying the length of the side, mind you, the length of the side will obviously change. It will either increase or decrease depending on whether we have enlarged or reduced respectively, right? But the ratio of the sides would always remain the same. Okay, so if I were to take the ratio of the length of the sides, they would be the same as the one before the original triangle, right? Before we enlarged it or reduced it. Now, trigonometry is based on this principle of any triangle. Now, trigonometry is applicable to any triangle. Although in this lesson, we are specifically going to learn trigonometry under the garb of right angle triangles, but we have a subsequent lesson wherein we will see how trigonometry can also be applicable to non-right angle triangles, right? But before we get into trigonometry, let's try and understand the different sides of a right angle triangle. So here's a right angle triangle with side lengths A, B, and C, small letters. And the angles are also A, B, and C, capital letters. So the side opposite to angle A is small a, the side opposite to angle B is small b, and the side opposite to angle C is small c. Now let's understand different terminologies, okay? Hypotenuse. We all know hypotenuse, right? We have learned this in Pythagoras theorem. Hypotenuse is the longest side of a right angle triangle, and it is the side opposite to 90 degrees angle. In our case, it is the side AB, which is represented by the letter C. So hypotenuse is the same, okay, for both the angles A and B. However, the other two terminologies, okay, opposite side and adjacent side, are specific to the angle that we are referring to. Although the hypotenuse is common in a right angle triangle, the opposite side and adjacent side will differ depending on which angle are we talking about. For example, if we are talking about angle A, if we are referring to angle A, the opposite side in this case would be small a, right? It's the CB, the side CB, which is represented by small letter A. The opposite side will be A. And the adjacent side would be the side which is not the hypotenuse and not opposite. Okay, so it is basically side AC, as you can see, which is represented by the letter B. Now you'll realize that the minute I change that to angle B, right now with our reference being angle B, the opposite side will change because now with respect to angle B, the side opposite to that is AC, which is represented by the letter B, small letter b. And the side adjacent to angle B is the side which is neither opposite nor the hypotenuse. In this case, that side is BC, which is represented by the letter A. So we need to first understand the terminologies, okay, referred to for each angle. So for hypotenuse, it's the same because hypotenuse of a triangle, a right triangle, is the same irrespective of what angle we are referring to. But the opposite side and the adjacent side will differ depending on which angle is the point of reference, right? Now, with this background, we are ready to learn trigonometric ratios. The first trigonometric ratio is sine of any angle. Sine of an angle is defined as the ratio opposite side to that of hypotenuse. Let's understand this using the same triangle again, right? Now, let's find the sine of angle A. As you can see the formula, opposite side for angle A is small a, right? So that goes in the numerator, and the adjacent side for that angle, sorry, for the hypotenuse of that angle, in fact, hypotenuse for the triangle is C. That goes in the denominator. So sine of angle A is given by the length of side A divided by length of side C, the ratio of the opposite side to the hypotenuse. Now, obviously, if we are referring to angle B, the sign would change because the point of reference has changed. So with respect to angle B, sine B would be given by opposite side again. Now, which is the side opposite to B? It is given by the small letter b. So that goes into the numerator, and the hypotenuse, which is C, goes in the denominator, right? So while sine of A is A over C, sine of B would be B over C. Now this is the first trigonometric ratio. Now sine of an angle is also given as sin, S-I-N in short. Okay, let's come to the second trigonometric ratio, and that is cosine of an angle. Cosine of an angle is defined as the adjacent side divided by the hypotenuse. Let's come back to the same triangle. What about cosine of angle A? Now, which is the adjacent side to angle A? As we saw earlier, adjacent side is the side which is neither opposite nor the hypotenuse. So in this case, it is the side referred to by the letter B. So small b goes into the numerator of the fraction. The denominator of cosine is hypotenuse, which in this case is C. So cosine of angle A is B divided by C. What's cosine of angle B then? In that case, we need to find the adjacent side to angle B. To angle B, opposite is B and hypotenuse is C. So the adjacent side would be side A. So that goes into the numerator. And hypotenuse goes into the denominator, which in this case is C. So cosine of angle A is B over C, while cosine of angle B is A over C. Now, cosine in short is referred to as cos. So cos of any angle is the same as cosine of any angle. Let's come to the third and the last trigonometric ratio, and that is tangent of an angle. Tangent of an angle is defined as the ratio or the fraction opposite side over the adjacent side. Well, let's come back to the same triangle. With respect to angle A, what is tangent of angle A? The definition says it's the opposite side to A, which is small letter a, divided by the adjacent side of A, which is small letter b. Correct? So tangent of A is given by A, that is small a over small b. Likewise, what is tangent of angle B now? With respect to angle B, tangent would be opposite side of angle B, which in this case is B, divided by the adjacent side of angle B, which is A. Right? So tangent of angle A is A over B, while tangent of angle B is B over A. Tangent, in short, is also referred to as tan. Let us then summarize the trigonometric ratios that we learned. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now these three trigonometric ratios can also be represented by the formula triangle, which looks like this. Now, many students use these formula triangles to remember these ratios very well. So you know how the formula triangles are used, right? So the quantities which are on top and the bottom are always divided, whereas the quantities at the bottom are always multiplied, which means S, which stands for sine, will be equal to opposite divided by hypotenuse. Likewise, if I need to find hypotenuse, then I'll do opposite over the sine of the angle. And if I need to find the opposite side, then I will do sine of the angle multiplied by the hypotenuse. So you should have known how to use the formula triangle. In short, people remember it like SOH, S-O-H, sine opposite hypotenuse, CA, which is cos adjacent hypotenuse, and TO, which is tan opposite adjacent. You can choose to remember it whichever ways you feel convenient. Now let us try and understand the relationships between trigonometric ratios. For that, let's bring this triangle back again. So we have sides ABC and angles ABC. The angles are in capital letters, and the side opposite to each angle are the corresponding letters in small. Now, we already have found out the sine, cos, and tan for each of these angles, right? Here are the fractions. Now let's try and derive some relationship between these trigonometric ratios. Now, if you look at it, okay, if you look at the angles carefully, you will realize that angle A and angle B should add up to 90 degrees because all three angles of a triangle should add up to 180 degrees. And if one of the angles is 90 degrees, the other two angles should add up to 90 degrees, right? Which means angle B can actually be written as 90 minus angle A. So what I'll do is on the table, I'll replace B with 90 minus A, right? Because A and B should add up to 90 degrees. So if one of them is A, the other one will be 90 minus A. Right. Now let's make some observations from the table. If I look at these two values, as you can see, sine of angle A is the same as cos of 90 minus A. Both of them are A over C, right? So sine of any angle theta is the same as cos of 90 minus theta. Likewise, if I look at these two values, they are again the same. So cos of A is the same as sine of 90 minus A. So cos of any angle theta is the same as sine of 90 minus that angle theta. Okay, let's get to some other relationship now. What do you observe in case of a tan? You'll realize that tan of any angle is the reciprocal of tan of 90 minus that angle, right? A over B, B over A. So tan of theta is the same as 1 over tan of 90 minus theta. An alternate way of saying this is the product of tan theta and tan 90 minus theta will always be 1. Right. Now look at these three columns. What do you observe? If I divide sine by cos, you'll have A over C divided by B over C. You'll be left with A over B, which is the tan. So sine over cos equals to tan. Let's check whether this applies to the other angle, 90 minus A. So B over C divided by A over C, as you can see, it is equal to B over A. So we can generalize this rule. Tan theta is the same as sine theta over cos theta. And finally, the last of the the relationship, which is also called as the trigonometric identity. Let's look at the sine of angle A and cos of angle A, and let's square them and add them. So sine A the whole squared plus cos A the whole squared. What will you get? It will be a fraction A over C the whole squared, which is A squared over C squared, plus fraction B over C the whole squared, which is B squared over C squared. Now, because both the fractions have the same denominator C squared, we can always add the numerators with this leaving the denominator same, right? A squared plus B squared over C squared. Now, if you look at the triangle carefully, the right angle triangle, if you apply the Pythagoras theorem, you'll realize that a squared plus b squared is actually the hypotenuse squared, which is c squared. So I'll replace a squared plus b squared by c squared to get c squared over c squared, which is equals to 1, which means we have derived an interesting relationship, and that is sine a squared plus cos a squared will be 1, which means if you square sine of any angle, add that to the square of cos of that angle, you'll always have addition as 1. Right. Having learned the relationship between the trigonometric ratios, we need to now know the trigonometric ratio for some standard angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You may choose to pause the video at this moment and make a note of these values. These are important values, and you need to remember these values. Now let's try and figure out whether the relationship that we derived earlier stands for these angles as well. For example, 30 degrees and 60 degrees are two angles which add to 90 degrees, right? So as you can see, sine of one angle is the cos of the other angle. Sine 30 is the same as cos of 60. Likewise, sine of 60 is the same as cos of 30, right? Remember, sine theta is cos of 90 minus theta. Cos theta is sine of 90 minus theta, right? What about the tan, okay? Are they the reciprocals? Yes, tan 30 and tan 60 are reciprocals of each other. Again, proving that tan theta is 1 over tan of 90 minus theta. Also, you'll find that if I divide the sine of any value, sine of any angle by the cos of any angle, you'll always get the tan of that angle. Make sure you remember these values very well. Well, that's the end of this session on basic trigonometry. What did we learn in this session? Well, three things. We learned what is trigonometry, what branch of mathematics is that, and we also learned about some basic trigonometric ratios. Then we went on to derive some relationship between these trigonometric ratios. And finally, we learned about the values of trigonometric ratios for some standard angles like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. I hope you understood the concept that you learned in this lesson. Thank you.